Bonjour and welcome back to the workshop for the second part of our Build Along series, and in this part we're going to be heat treating our blanks. So in the first video of the series, which we did last week, we designed our blank, and it's been really great to see some of you working along with us, building along with us and making your own blades using the Knifetalk BA hashtag. And it's been nice to see some modifications that people are doing as well. But I designed it on knifeprint.com, and you can look down in the description for that previous video and discounts and so on. But if we take a look at the blade that I've got, so this was shipped by knifeprint.com, and it's all ready to be used. But there are a few changes that I want to do. When I made the initial design before I got it printed, I started with 1/4-inch holes for pins. But I now think I want to use Corby bolts. So I'm going to add extra holes into the tang area, which is the handle. And we really want to be doing that before we harden the blade, because it's going to be very hard to drill otherwise. And there is just a little bit of mill scale on there. So we have a look at the blade. You can just see there's a bit of mill scale there. So we want to clean that up before we get onto the hardening process. So let's jump into the grinding room and get that done. Okay, so now we've got our clean blade and it's all ready for heat treating, but there are a few adjustments that I want to make. So first off, I'm going to mark where the handle is going to be, and I'm going to do that just with a marker pen. And it's going to be around about, just about there. So that's where the scales will come on the blade. Now I do want to change these holes, or add additional holes rather, for new pins. So I think they're going to be just to the right of the current pins. And they're going to be for the Corby bolts. And the other thing that I want to do is, as I say, it's been nice to see some really nice modifications people do into the blade. So I'm going to put some finger grooves just across the top there. So I'm just going to mark out where they're going to be. And for me, it's around about there. So between that area is where I'm going to file in my finger grooves. And we need to do that before the blade is hardened. So we'll do that first, and then we'll just mark out with a punch exactly where we want those holes to be. Now, using a digital caliper set to around 3mm in this case, I'm just going to mark across the spine of the knife exactly where I want those grooves to be, ready for my hand filing. Then I'll clamp the blade into a vise, and using a set of diamond warping files, and I'm just using two here. So this one is triangular in profile and this one is round. What I'll do, I'll first of all start with the triangular using one of the edges just to make a groove in each of those marks along the spine. So in alternate sides, obviously, for the particular shape that I'm doing now at least. And once I've got those grooves, they make a perfect seating for the circular file to go in and just finish those off. So bear with me just while I do that. Just making sure they're perfectly on the lines which I've already scribed. And I'm just making a small indent there, just enough for the round file to fall into. So now I'm going to skip the next line and go to the third line in the series. So I'm doing 1, 3, 5, and 7. And then I'm just going to flip the blade around and do the same on the opposite sides in the alternate holes. So 2, 4, 6, 8. So I've punched some holes in the knife, some indents ready for drilling. So just make sure you get the right drill bit. So in this case, I'm using a 4.7mm bit, which is for my Corby bolts, the shaft of the Corby bolts. You want to make sure your drill is on the slowest speed. So a lot of these drills, you will find that there's a pulley system. So make sure it's on the slowest speed for steel. What I like to do is just pull up the table as close to the bottom of the bit as possible. That way you know you're going to get the best angle possible. And safety first, kids. Clamp your material down. So now I've got the holes drilled. What I'm going to do is just drill a few more holes to take out some of the weight in this handle. Then also use a chamfered bit just to take off any burrs that we may have on the edge there. But we're starting to look good. Okay, so now we've got our blade all cleaned up. We've got the holes exactly where we want them and everything's nice and clean. It's now time to do the technical bit, which is to harden the blade. And that's quite a technical process where the microstructure of the actual steel, we need to get to an austenite phase, which normally happens around about 900 degrees C, which is around about 15 to 1600 degrees Fahrenheit. We then need to quench the blade so it cools down very, very quickly, which will then convert the austenite into martensite, which is what we need for a hard blade. So I'm going to be using an even heat oven. If you don't have any electronic temperature controlled kiln, you can use a forge, or at a push even maybe use torches. But we talk about that in this week's episode of Knife Talk at knifetalk.net. But as I say, I'm going to be using one of these even heats. Now, different types of steel are heated in different ways, such as to different temperatures, depending on, I suppose, the ingredients within the steel. Now, most steel manufacturers will generally publish the heat treating guidelines for their steel. And I've got a particular recipe which I use for O1, and that is to heat the oven up to 1200 degrees Fahrenheit, which is around about 610 degrees Celsius, or 640 degrees Celsius. I then add the steel for 20 minutes. I then ramp straight up to around about 1510 Fahrenheit, which is about 820 degrees C for 15 minutes before plunging into the oil. And what I've done here, I've actually loaded up the oven with a few little plates, such as this. And I'll use that to heat up the oil just before I go plunging the knife into the oil. So let's program this up. Quite simple, so I'm going to develop a new program. I'm going to have two segments to this. So the first is that initial 1200 degrees Fahrenheit. I'm going to hold that for 20 minutes. So I'm going to ramp up as fast as I can. So I want 1200 degrees. I want that held for 20 minutes, which I already have. Ramp 2 as fast as I can. And this is going to be to 1510. And that's going to be for another 15 minutes. And we want an alarm. So that's complete. So I can hit run, enter. And now the oven is going to heat up to that first temperature, which is 1200 degrees Fahrenheit. Whilst the oven is heating up, you may want to practice the procedure of taking the knife out of the oven and into the quench a few times, just so you know that everything's going to be running nice and smooth, and most importantly, that you have everything that you need. Okay, we've had a bit of a disaster. The camera that I was using, this Canon here, I dropped straight onto the lens and it's no longer focusing. So we're now going to be using my iPhone for the rest of this video, unfortunately. So the oven hit 1200 degrees. I put the knife in. It sat in there for 20 minutes and now it's just starting to ramp up to its final temperature of 1510, and that's in Fahrenheit. So once that happens, I'm going to take the knife back out, we're going to quench it, and we should be good to go. So now we're nearly at temperature. What I'm going to do is take out some of those strips of steel we had just to warm up the steel. Sorry, to warm up the oil. So let's take one of those. Shut that behind me and straight in. And that's just going to warm up the oil for us to make it the correct viscosity, ready for quenching our blade. So the blade's been held at 1510 for around about 15-20 minutes now. So I've got my oil ready, that's nice and warm. And what I'm going to do is in one solid motion. So I'm going to pick up the blade, bring it down straight into the quench tank. Okay, here it goes. Make sure you're wearing gloves for this. You just want to move it, just to move those bubbles from the surface of the steel. There we go. That's one hard blade. So now that's ready for tempering cycles. So I'll generally put this back into the oven, run about 400 degrees Fahrenheit. For 2 one-hour sessions, and what that will do, that'll just bring down the brittleness and the hardness of that blade, just so they can be sharpened and it's a lot more durable. There we go. Perfect.